and the Earth's energy budget and everything. Now we're going to talk about the reason for the seasons. So I'm sure you notice it, especially if you live here in California, that we have a time of the year that's very warm. Just like everybody else, we call that summer. We have a time of the year that's very cold, and just like everybody else, we call that winter. But why exactly do we have seasons? Well, today we're going to be talking about that. So the first thing we're going to talk about is actually knowing how the distance from the sun changes throughout the year. Believe it or not, Earth's orbit is not perfectly circular. And so there's actually a time of the year where the Earth is farther away from the sun and a time of the year where Earth's closer to the sun. The second thing we're going to talk about is Earth's tilt and how that affects where incoming sunlight is most intense. And then finally, we're going to talk about how the angle of incoming sunlight affects a location's temperature, which we talked a little bit about that in the previous lecture. And if you're watching this from my face-to-face class, I showed a demonstration in class about that. So, but I'm going to show it again for this video. All right, so let's jump in. So first off, let's talk about Earth's orbit. So we know that we're on a big blue ball that's orbiting the sun. And believe it or not, Earth's orbit is not perfectly circular. Rather, it's slightly elliptical. The one interesting thing about Earth's orbit is that it's completely horizontal. And what I mean by that is that as the Earth is circulating around the sun, it doesn't move up or down. It just travels around the sun in one plane circle. And if you've remembered from previous math classes, a plane is simply just a flat space. It's just a flat, two-dimensional space. So in a sense, Earth's orbit is a two-dimensional orbit. And we call this plane that the Earth orbits on the plane of the ecliptic. And we're going to talk about that in a second because Earth's axis is tilted at an angle relative to the plane of the ecliptic. So Earth's orbit's not a perfect circle. That actually gives us an interesting implication. And the interesting implication is that there's a time of the year where the Earth is closer to the sun and a time of the year where the Earth is farther from the sun. Now, if this was my face-to-face class, I would be asking you, so what time do you think it's closest? What time do you think it's farthest? And about 90% of people would say, oh, well, it must be closest in June, July, and August, and farthest in January, February, and March. Yep, that's us. We're what are called Eurocentric people. We think that everything that happens in the Northern Hemisphere is what happens everywhere. But believe it or not, seasons in the Southern Hemisphere are flipped. So it wouldn't make sense for them to be closest in January, farthest, or closest in July, farthest in January. And so believe it or not, Earth's orbit, at least the distance from the sun, has very little influence on our seasons. And as a matter of fact, Earth is actually closest to the sun in January. And astronomers have a name for that. They call it perihelion. That's just the time of the year that the Earth is closest to the sun. And at that time, the Earth is 147 million kilometers away from the sun. So it's a little bit closer. On the other hand, in July, the day that we're all lighting fireworks and having barbecues and celebrating the birth of our nation, on the 4th of July is actually aphelion. And as I jokingly suggest to all my classes, this year on the 4th of July, run around and yell, Happy Aphelion! And everybody will point and laugh at you. But that's the day that we're the farthest from the sun. So we're closest in January, specifically on January 3rd, and farthest in July, specifically on July 4th. Now these days do shift with what are called the Milankovitch cycles. We'll talk about those Milankovitch cycles when we get into climate change, and that's towards the end of the course. But now let's talk about the elephant in the room. What's the real reason why Earth has seasons? Well, it all has to do with the fact that the Earth's axis does not stand straight up relative to the plane of the ecliptic. So think about it. if you were standing right now on a floor, let's suppose that the floor is the plane of the ecliptic, and you're standing straight up. That's what's called perpendicular. Earth's axis does not stand straight up. Rather, it's tilted at an angle of 23.5 degrees. Now, this is important because this actually means that as the Earth is orbiting the sun, there's actually a time of the year where one hemisphere is getting more sunlight than the other hemisphere. And you can actually see that in this diagram here. In this diagram, if I were to split the Earth up into half, what you would actually notice, and let's split it up into half along the equator, that's this line right here. What you would actually notice is that more of the northern half is getting sunlight than the southern half. The southern half is actually getting less sunlight. This is what we actually experience from March until September, our spring and summer months. On the other hand, during the winter time, the fall and winter time, we would be getting less sunlight and the southern hemisphere would be getting more sunlight. So it all has to do with tilt. Because of this, again, one hemisphere gets more sunlight than the other. From March to September, it's us in the northern hemisphere. We're north of the equator, we get more sunlight. And therefore, that's when our spring and summer are. Spring is March through June, summer is June through September. On the other hand, during the fall and winter months, from September to December and then December to March, more sunlight is shining in the southern hemisphere. So we get less, hence we're colder. And then for the southern hemisphere, they get more sunlight in the months of September to March. So that's when their summer is. Their spring is September through December, and their summer is December through March. So in a sense, and then their fall is from March through June, and then winter's from June through September. So again, in a sense, what this actually means is that when you cross into the other hemisphere, seasons flip. You literally are now in the opposite season. So when it's spring here, it's fall down there. When it's summer here, it's winter down there. When it's winter here, it's summer down there, and so on. Now, how does this angle of sunlight actually influence temperatures and so on? We'll talk about that in a minute. But just showing you here, this is basically the path of Earth's orbit. So it's orbiting on that flat plane, the plane of the ecliptic. Its tilt is 23.5 degrees. One thing I should highlight here is that the direction of Earth's tilt does not change throughout the year. The direction of Earth's tilt is always pointing towards Polaris, the North Star. And the North Star is somewhere way up over here. Way up over here. Now, interestingly enough, over a period of roughly 11 to 12,000 years, the direction will actually flip to a star over here called Vega. If you've ever seen the movie Contact, it's the same Vega from that movie. If you haven't seen the movie Contact, you're better off for it. But that's what happens with Earth's tilt. So as a result, as the Earth is traveling around the sun, the tilt either points towards the sun, such as over here, that North Pole points towards the sun over here, and that's why we get our spring and summer months. We're facing the sun, we're getting more sunlight. And then over here, the South Pole is pointing towards the sun, and therefore the southern hemisphere is getting more sunlight. There's some interesting implications that this has that we'll talk about in our next video. So, with this said, there are a few important days that I want you to remember. Now, for the most part in this class, dates aren't important except for on Friday and Saturday night. But for this particular time, there are a few days that I do want you to know about. And those days are, here in the Northern Hemisphere, our summer solstice occurs on June 21st or 22nd, depending on what time zone you're in. On that day, the sun is the farthest north overhead. The sun is directly over 23.5 degrees north. And we call that latitude the Tropic of Cancer. This is the farthest north that the sun travels, and so this is the farthest north that the sun's overhead. After this day, this also marks the first day of astronomical summer. After this day, the sun begins moving south. And 6 months later, on December 21st or 22nd, again, depending on what latitude you're at, the sun is directly over 23.5 degrees south. That's called the Tropic of Capricorn. And on that day, that's what our winter solstice is. On that day, that's the farthest south that the sun travels. It's the first day of astronomical winter. And after that day, the sun begins making its journey back to the north. So this is just an image of the Earth right around the summer solstice. So at this point, the sun is directly overhead. So the sun's over here somewhere. And it's directly overhead at 23.5 degrees north. In this case, if you take a look, the northern hemisphere is getting a lot more sunlight. And as a matter of fact, as you get closer to the pole, something interesting happens. You end up getting into a region that gets 24 hours of sunlight. So imagine that, a day that never ends. Try sleeping in that. On the other hand, the southern hemisphere, down here, is experiencing winter. And whereas the North Pole is experiencing a 24-hour day, the South Pole is experiencing a 24-hour night. Nothing at all. No sunlight at all. Imagine trying to be productive on a day like that. And then 6 months later, when we go into our fall and winter, and the southern hemisphere is in its spring and summer, now we have the sun directly overhead at 23.5 degrees south. And at this point, the southern hemisphere is getting a tremendous amount of sunlight, whereas the northern hemisphere is getting much less sunlight. And again, consequentially, the North Pole now has a 24-hour night. And there are actually cities pretty close to up here in what's called the Arctic Circle that actually get a 24-hour night. Barrow, Alaska is an example of that. Meanwhile, down here, the South Pole is getting 24 hours of day. So that is a major change from one season to another. You have a 24-hour night in the winter, 24-hour day in the summer. This creates great temperature variation, which we'll again talk about in the next lecture. So there's two other important days I wanted to mention. So during the summer solstice, the sun is directly overhead at the Tropic of Cancer. That's 23.5 degrees north. On the winter solstice, it's directly overhead at 23.5 degrees south. That's the Tropic of Capricorn. However, there are 2 days a year where the sun is directly over the equator. And we call these days equinoxes. And on these 2 days, both hemispheres, the northern and the southern, are getting equal amounts of sunlight. And as a result, they each get approximately 12-hour days. Now, there's a little variation in that because of what's called refraction. Basically, as sunlight enters the atmosphere, it bends a little bit. That has to do with atmospheric optics. It's a little beyond what we're going to be talking about today. But that slightly lengthens the daytime, but not much. What I do want you to know is that these spring equinoxes occur on March 21st or 22nd, again, depending on what time zone you're in. And then the autumnal equinox occurs on September 22nd or 23rd. And again, depending on what time zone you're in. So this is how the Earth looks during each of these different days, during each of these different important days. So here during the two equinoxes, you can notice that both hemispheres are getting equal amounts of light. The northern hemisphere is getting equal amounts of light to the southern hemisphere. And then the same is true in September. On the other hand, in June, this is our summer solstice, the northern hemisphere is getting more sunlight. And then in December, the northern hemisphere is getting more sunlight. And then in December, the southern hemisphere is getting more sunlight. Now, one thing I'll talk about with this whole thing is that seasons impact two things. And the two things that they impact are first, the angle of incoming sunlight, and second, the length of the day. So when the sun is in your hemisphere, that means that the sun is higher in the sky. When the sun is higher in the sky, its radiation is more intense. To show you what I mean, let me show you a little demonstration. So let me really quickly open up my webcam. There we go. Hello. Let me get this right here. Trying to see if I can get it bigger. No, I can't. Okay, well, anyway, here I have a clipboard and a flashlight. All right. So now let's show you what happens when the sun is directly overhead. When the sun is directly overhead, the beam of radiation is concentrated on the surface. That means that you have a small area that's very well illuminated. But watch what happens when the sun comes in at a lower angle, like so. Two things are happening to that illuminated surface. The first one is it's elongating. That would seem like a good thing. Okay, so when the sun's lower on the horizon, that means more areas getting sunlight, right? Nah, not so much. The other thing that's happening, though, is if you notice when the sun is directly overhead, that illuminated area is actually very bright. But when the sun's low on the horizon, it's much dimmer. This is one of the reasons why when the sun is lower in the sky, it seems like it's darker, it's cooler. This is why that happens. I'm going to take that away. And I'm going to move on now, so I'm also going to take this away. Hang on here, I gotta. Alright, let's get that away. Bye. Alright, so now let's talk a little bit more about this. So, seasons greatly affect the amount of incoming radiation. And this affects not just the angle of incoming sunlight, but also the length of the day. So, during the winter time, the sun is lower in the sky, and it's also out for a much shorter period of time. So now you have very dim light over a very short period of time. So it's going to be pretty cold. On the other hand, in the summertime, the sun's much higher in the sky, so you get much brighter light, much more concentrated sunlight, and it's out for a longer time. Hence, it's warmer. So again, both of these things are greatly impacted by what time of year it is, what position the Earth is relative to the sun, and the angle of Earth's tilt relative to the sun. Now, I just talked about this, but just a quick review of it. We actually have a fancy name for this angle that the sun is coming in at. We call it the angle of insolation. Let me explain what insolation means. In means incoming, sol means solar, ation means radiation. So when we're talking about the angle of insolation, we're talking about the angle with which sunlight's coming in. Again, when the sun is directly overhead, the angle of insolation is 90 degrees. And in that case, the sun's coming straight in, and it's illuminating a smaller area. And since it's illuminating a smaller area, all of that sunlight is concentrated. So you're getting intense sunlight. On the other hand, when the angle of insolation is lower, the amount of incoming sunlight, the amount of insolation is actually much, much more spread out, hence much weaker. Much weaker. And then when the sun dips below the horizon, you've got nothing coming in. The last thing I'll talk about is how seasons are influenced by latitude. If you live near the equator in what are called the tropical latitudes, this is 0 to 23.5 degrees, you are in a region that has the sun almost completely overhead. The angle of incoming sunlight, the angle of insolation, isn't going to change much throughout the year. It's going to vary about 23.5 degrees to the right, then 23.5 degrees to the left, but in any of those cases, it's still really high in the sky. And so you're getting plenty of direct sunlight year round. Hence, those locations are typically very warm. The other interesting thing, though, is not only are they very warm, but they're constantly warm because you have high sun in the sky year round. So there's no real cold season, and there's no real warm season either. It's just warm year round. Now, the further away you get from the equator, though, the more and more variation you're going to get. So if you live in the mid-latitudes, this is between 23.5 and 66.5 degrees, either north or south of the equator, so in either hemisphere. You get plenty of direct sunlight, almost intense sunlight in the summer, almost the same amount of sunlight that the equator gets in the summer. But in the winter, you get substantially less sunlight. And so there's actually a noticeable variation from one season to another. There's noticeable variation. And then finally, when you get into the polar latitudes, here you have extreme variation. In this case, you get plenty of sunlight, but it's at a low angle during the summer months. However, again, it's out for 24 straight hours, so in that case, you're still getting a lot of sunlight. So you're usually nice and warm, relatively speaking, in the summer. On the other hand, in the winter, the sun is below the horizon, and so you're just getting never-ending twilight. Little, if any, in the wintertime, so it's very, very cold. Now, we're going to talk about how this actually influences temperature cycles in the next lecture. But until then, let me just wish you happy holidays from Australia. Because guess what? When we're up here bundled up, opening presents under the holiday tree, celebrating Hanukkah, Thanksgiving, Christmas, Kwanzaa, or whatever holidays you celebrate during that season, New Year's and so on, they're down there having barbecues, going surfing. They're not bundling up. And in fact, as Santa crosses the equator, he has to completely change into new clothes because it's just so warm down there. So, happy holidays from Australia. And that's it for this lecture. If you're in my on-campus class, we'll be talking more about temperature in the next week. If you're in my online class, we'll be talking about it right after this. Thank you for watching, and I'll see you next time.